Welcome to your Deep Focus Exam Strategy session. Today, we are completely demystifying Cambridge AS and A-level mathematics, specifically zooming in on syllabus code 9709. Our core objective for this explainer is simple. We are going to transform your approach from anxious test-taking to calm, calculated mastery. Take a breath, let your focus settle, and let's look at a topic that forms the absolute bedrock of your mathematical architecture, which is circular measure. We are going to decode exactly what it takes to secure top marks without the stress. Mastering circular measure isn't just a casual suggestion. It's a direct mandate from a senior Cambridge examiner. It is absolutely essential for success, and it appears in every single examination series. I really want you to absorb the weight of that statement for a moment. In the wildly unpredictable landscape of advanced mathematics, where you never quite know which exact permutation of calculus or trigonometry might show up on page 4, circular measure is your anchor. It's an unavoidable pillar of the exam. And honestly, because we know with absolute certainty that it will be there, we can meticulously plan for it. We don't have to fear it, we can completely engineer our success around it. When you walk into that exam hall knowing exactly how to extract these marks smoothly, it sets a serene, confident tone for your entire paper. To achieve this state of mastery, we'll be following a highly organized 4-step blueprint today. 1. Theoretical foundations. 2. The procedural framework. 3. The method mark strategy. And 4. Critical examiner warnings. Let's calmly step into step 1. Section 1. Theoretical foundations. Let's lock in the core principles of circular measure before we look at the exam strategy itself. The entire theoretical architecture of circular measure rests on precise definitions and causal relationships. First up, the concept of radians. Now, this is not just some alternative to degrees. It is a mathematically pure way of relating angle to radius and arc. It's literally the language that makes calculus and advanced geometry possible. Then, we have the arc length formula, where S equals r theta. It is simple, it's elegant, and it's directly proportional. Finally, the sector area, where A equals 1/2 r squared theta. Knowing these formulas is merely the baseline expectation. When you are sitting there, I want you to mentally visualize the sector of a circle. See the radius sweeping through the angle, carving out the arc, and enclosing the area. This visual clarity is exactly what keeps you grounded when the exam questions start becoming multi-layered and complex. We are just peeling back the filler words and looking at the pure math. Here is a crucial secret extracted directly from the principal examiner reports. Candidates who reference cross-topic connections achieve significantly higher marks. Cambridge is never testing circular measure in a vacuum. The assessment framework heavily prioritizes analytical depth and connected conceptual understanding over superficial breadth. So, what does that actually mean for your study session? It means you have to balance two different mindsets. You need the precision of a highly analytical scholar who maps out definitions perfectly, but you also need the dynamic creativity of a scholar who links concepts together. You might be asked to find the area of a sector, but to even get to that starting line, you might first need to calmly use the cosine rule from trigonometry to find an angle, or maybe solve a quadratic equation to find an intersecting radius. You must be prepared to seamlessly weave different threads of your mathematical knowledge together. Moving smoothly into section 2, the procedural framework. Let's shift your perspective from passive learner to active examiner and look at the technical methodology. To succeed in a high-pressure exam environment without losing your rhythm, a strict, standardized sequence is necessary. Step 1. Deconstruct the question and extract data. This is where you mentally highlight and isolate the givens. What's the radius? Is the angle in radians or degrees? Just extract it. Step 2. Select the analytical framework. Are we hunting for a perimeter, an area, or maybe a shaded region combining a triangle and a sector? Step 3. Execute with clear notation. This is where precision shines. You write it out beautifully and cleanly. And step 4, present with correct terminology. Maintain total focus on the specific command word parameters. Did they ask you to evaluate or analyze? This procedural flow is completely non-negotiable. Data extraction and clear formatting are the exact conventions that examiners demand to award you those top band marks. Section 3, the method mark strategy. This is all about capturing your process points. Let's breathe and refocus for a second. Before we write out our final top band paragraph structure, make sure your daily study dashboard is complete. Subscribe to Ace the Exams right now and enable all notification alerts. Whether your target is an IGCSE, an O-level, or an AS and A-level A-star, this channel is your weekly space for stress-free exam mastery. Okay, back to the strategy. This is the beautiful reality of Cambridge exams. The examiner actually awards points for your logical reasoning process, even if your final numerical answer slips up due to a minor calculator error. Your process is your insurance policy. To capture every single one of those process points, you need to adopt the deconstruct, solve, evaluate mantra. First, deconstruct. State the formula clearly. That's your pristine baseline. Second, solve systematically. Substitute your extracted data into the formula, showing the exact substitution step. Don't just jump to the answer. Show the machinery working quietly in the background. Finally, evaluate for reasonableness. Does an area of 500 square centimeters actually make sense for a sector with a 2-centimeter radius? Definitely not. This specific structure restores balance to your page and ensures your evidence remains perfectly aligned. This beautifully transitions us into higher-order evaluative thinking. If you hit a structural roadblock mid-calculation, top-scoring candidates don't panic. They exhibit 3 key behaviors. First, they question assumptions. If a diagram is clearly labeled not to scale, they do not assume a line is a diameter just because it looks like one. Second, they consider different perspectives. Is it faster to calculate the area of the major sector directly, or should we calculate the minor sector and subtract it from the whole? They calmly weigh the alternatives. And most importantly, they justify decisions with evidence. If you conclude that a specific angle must be obtuse, you have to show the geometric or trigonometric proof that led you there. By writing out your mathematical response line by line using these exact behaviors, you are essentially guiding the examiner's pen straight to your maximum score. Section 4. Critical Examiner Warnings. Let's do a mindful scan of the top pitfalls in circular measure so you can just step right over them. Welcome to the visual practice arena. The reports explicitly cite these top 3 mistakes, and we are going to analyze them with complete clarity. First, answers are too vague, lacking specific details. In circular measure, this usually means writing down a final answer without showing that crucial intermediate angle calculation. The examiner cannot guess your brilliance. You literally have to put it on the page. Second, forgetting to check format and presentation. Did the question ask for the answer to 3 significant figures or exact form in terms of pi? Losing a mark because you rounded to 1 decimal place instead of 3 is a painful, unforced error. Third, providing generic answers not specific to the context. If the question is modeling the sweep of a windshield wiper, your final statement shouldn't just be A equals 45. It needs to relate back to the physical area cleared by that specific wiper mechanism. Look at the stark contrast we have here between an imperfect answer and a flawless one. A generic response is completely detached from the problem. It is just writing down formulas and hoping they stick without tying them to the physical geometry presented in the exam paper. A context-specific response, however, links every single point to the scenario. It is the difference between writing, I found the angle, and writing, I calculated angle AOB using the cosine rule in triangle AOB, which is required to find the area of sector AOB. It sounds incredibly formal, I know, but that rigorous structural discipline is exactly what secures the top band marks. When you write like this, you are effectively proving to the examiner that you are in complete control of the mathematical narrative. So I'll leave you with this. When you write your next proof, will your structure secure the method marks, or will you lose them to a generic answer? We've distilled this entire masterclass down into core focus pillars: decoding the command words, managing your procedural flow, and executing that final polish review pass to avoid the classic pitfalls. The examiner's blueprint is now completely in your hands. Subscribe to AC Exams, click the notification bell for future focused deployments, and leave a comment below identifying the specific subject, tier, and target grade you are currently meditating on. Stay focused, and I'll see you in the next session.